Okay, projectiles is one new topic we are going to cover today, but please don't forget to subscribe to the channel. Whenever you want these videos, you can go to my playlists, then you will find all the topics purely arranged in their order. So let us start with this topic, projectiles, then we shall see. Let us start with the definition, what we will expect from this, and then after, we are going to see how you can handle them. So let us start with the definition of a projectile. A projectile is a particle which is given an initial velocity and then moves freely under gravity. So, a projectile is that particle that when you push or you give a certain force, that force you give it, we only assume that that one is going to move only under the influence of gravity from either the ground or above, as long as you are giving it an initial velocity. It's assumed that the only force acting on the particle is gravity, and so here resistance is assumed to be negligible. So here we assume that the hair resistance and so on, they don't act on that particle. If they are there, they are very small that cannot cause any effect on it. Common terms in the projectile, we have what we call a projectile. This is the path described by a projectile. So when this particle is moving, that path that it creates is what we call a trajectory. Angle of projection is an angle, the initial velocity makes with the horizontal, we are going to see it here. Then the range is the horizontal distance covered by the particle. I'm going to be referring to this diagram here. So this distance from here to here is what we call the range. When you throw this particle, this is now the particle. So this path it's creating through here is what we call a trajectory. Then this distance it moves until when it comes back to the initial position is what we call the range. It's always noted by R. Then maximum range is the greatest horizontal distance covered by the particle. So how far this particle is going to move, that's what we call the maximum range. Then the maximum height is the greatest height reached by the projectile. This one, I think this is not the greatest height at which this projectile will be. When something goes like this, there's this height it reaches before it falls down. So that's what we call the height. And then the time of the flight is the time taken for projectile to complete a motion. What do you mean by completing a motion? It completes a motion when after reaching the maximum height, it comes back to this initial point. So that the point is the same even though, but now the level at which it started is the level which is at now. Then the time it takes this projectile come back to that level, same level, is what we call the time of the flight. Or to return to the point of projection. Not like coming back, but to be on the same level with the point of projection. So consider projectile, a particle projected at an angle theta with an initial speed is. So when they give it an initial speed, so that now this one is being pushed from the ground, you see it's being pushed up there. So this is the angle which the initial velocity makes with the horizontal. This is what we call now the horizontal. Is what we call the theta. It's not the angle of projection. This angle of projection is always the angle between the initial speed given to the particle and then the horizontal. Then this is the height here, you see, then this is area. So now after here, it's coming here. So this is going to be my projection. Now this path it creates is the trajectory. As you see here, use the initial speed, time taken to cover r from here to here, then range, distance covered by r, this distance from here to here, then the angle direction. Now, under projectiles, we are going to basically see three cases here. Now, the first case will be this one. But let us start with these ones, then we shall come to this. A particle projected horizontally from a height above the ground at an angle either below the horizontal or above the horizontal. Now, this one now is starting. If this is the ground, now this particle is projected a bit up. So it's projected a bit up from the ground, this ground here. Now this is going to be our horizontal. Now it's that this initial speed, no velocity given to the particle, you see it's below. It makes the angle with it, but below the horizontal. So this is one case, but it's above. Also another case is when it's above, but then it's projected. This one is here, it's projected downwards, but this one is here, so the angle it makes with the horizontal, it's above. then it will be given, but it's also still above the ground. So already this is what we call our horizontal there. So this angle, it makes with the horizontal. Here is what we are going to see in that case. The angle is either below or above the horizontal. All of them at a certain height up there. Then the case 2, a particle projected upwards from a level ground. So now this is our ground. So it's projected from here. It's going to make that up when it comes back here. That's another case. Then 3, a particle projected horizontally from a height above the ground when the initial motion of the projectile is horizontal. Now we'll see, this one is almost similar to this. But here, this initial velocity is the same as it's going in the direction of that horizontal, as if you can see it here. It's going in the direction of that horizontal. So most people call this the horizontal projection. So probably those are the 3 cases we are going to see in our projectiles. We are going to see how to calculate the time of the height, this distance, and so on. So that's it, members. Please don't forget to subscribe to the channel. I wish you well. Wait for the next lesson. We are going to see how we go. We are going to see more examples given here. Then we shall see all the formula for all these trajectory equations when we come to this condition here. So see you there.